a higher population into these seminars. Anyway, today we've got Anish Patel, who is, as I understand it, you can correct me if I'm wrong, engineering technical manager for Trimble in Leeds, UK. So we appreciate that you are willing to join us and give us a little bit of an overview of Tekla structural designers. So with that, I'm going to turn it over to you.
Perfect. So can I share my screen? It should be able to. And let's see which screen. I'll share screen 2. And I'm just going to pop up a PowerPoint. And can someone just give me a shout when they can see the PowerPoint? Yeah.
Yeah, it's working.
So, pleasure everybody. My name is Anish Patel. I am I got introduced. I'm the engineering technical manager, which basically it's not as great as it sounds. It's basically I've been a structural engineer for 20 plus years in the industry. I've done everything from analysis and design to drawing in a drawing office, to actually setting out on site, to pouring concrete, to being a steel erector. So I did that for the first part of my career. I then joined CSC 18 plus years ago, and I've been specializing in analysis and design software for structural engineers. Everything at the moment is about BIM, which is, we call it Building Information Management. And again, I've used things like 3D Plus, AutoCAD, Autodesk Revit, and Tekla Structures. And my role at Trimble is basically I develop, support, consult. I teach on A&D processes and structural BIM technology around the world. And I'm responsible for basically the A&D code compliant modeling, the sales and service channels, and the BIM solutions in Trimble. So again, that's just a little bit about me. Just a little bit about Trimble. We're a massive company. It's really huge what we do. And sometimes I have to take a step back just to realize that we are in agriculture. These are just the core business franchises: agriculture, building, civil and engineering, construction, geospatial, transports and logistics. So again, mining, heavy machinery, and so things like that, we've got a part in there. My areas of expertise is in buildings, and we have currently 20 offices with around the world, with over 100 customers in countries. So again, I'm actually based in the UK, in Leeds, which is now just gone past 10 past 7 in the evening. But again, we've got offices around the world. And the beauty of Trimble is that we do have a global system and a 24-hour system, because we have global help desk as well. So again, you are never on your own. So what is the life cycle of a building? Okay, this is it. As engineers and people in the engineering sector, you've got to have this mental attitude of basically you've got to understand that the whole life cycle of the building ends up being your responsibility. Now, you may be able to give that responsibility away further down the line, but you need to have an idea of what that life cycle could possibly be. Now, in the UK, which I can talk about, every building that is constructed has a minimum life cycle of 25 years. In that 25 years, that building could be built. It could then change internally. You could have office areas, you could have workspace areas. You can have a whole load of things within that lifespan of the building that is valuable to that building, but can be used for lots of different things. So again, this is just a simplified method of basically, you've got to plan something, you've got to understand the concept, you've got to engineer it and design it, you've got to win it. And that's a really big one. But then once you've won it, you've then got to fabricate, construct it, manage it, and then again, utilize, optimize, change it. And there's a part in here that is missing, because then you might have to demolish it and start again. Okay, so the life cycle of buildings is always continuous and always changing. We have in Trimble several pieces of engineering technology or software concepts that allow you to plan, control, and do certain parts of this. And what we're going to concentrate especially is the Tekla side of things, is basically in the concept stage, design and engineering stage, and then even in the planning stage as well. Okay. Obviously, when you bid and award it, you've got to have a commercial mind, you've got to have a competitive mind, and you've got to be able to basically see what the competition is doing. But then once you get into fabricate and construct, the whole idea of this is basically, can you communicate from one part to another part, but then the other partner involved understands your concept and understand the information that you're giving and so on. And this for us is the whole life cycle of BIM, which is building information management, of trying to pass this information around. But our industry is not good. I am sorry to say. It doesn't matter where I go in the world. And I've been to all 5 continents. I've been to several projects. I've actually consulted on several projects. And the biggest thing about every other construction sector is that they've improved over time, except we haven't. We still lag behind, and the biggest thing for us is that 90%, and this is a really big 90%, of all our projects are late and over budget. It happens. You think of any project around the world and it's gone, oh, we estimated the initial budget wrong. I'm sorry, how do you do that? When you're supposed to be engineers, you're supposed to look to the future, you're supposed to try to get, yes, you can be over budget a little bit, but not as big as it makes the newspapers and it makes the news, that all of a sudden, wow, how far we are over budget. And this is mostly due to ineffective planning, communication, and collaboration. I'm sorry, but this is it. Does the person further down the channel understand what your concepts, your ideas are, or what you're actually trying to propose? That's the main part of this. And unfortunately, it leads to massive misguided interpretations from the public about our industry. And it's all about money and the time lost in producing what we said we were going to produce. But the biggest area is this one here, and it's the cost of construction rework. Is what you intended, what actually got built, and then all of a sudden it's not what you intended, and therefore now you have to sort of rework it. And unfortunately, being in the industry that we are in, we are in the repetitive industry of doing things over and over and over again. So I'm just going to talk about the Tekla engineering portfolio. Okay, so what we're going to see today is something called Tekla Structural Designer. It's our 3D structural analysis and design package, and you'll see that today. But I have also got another seminar, I think it's in a fortnight's time, when I'm going to show you Tekla TEDS. Now, Tekla TEDS is our hand calculation tool, which is our automated hand calculation tool available for all engineers. But we then have a BIM system, and the BIM system is called Tekla Structures. And this is our detailing and fabrication system. And this is where we actually put in the detailed imagery, or we can call it drawings, or whatever you want to say, of what we want to build. Okay, now there's a huge difference between the imagery or the details that we want to build in an analysis and design concept to what we want to actually put into our BIM model. And I can talk about this a little bit later on, but again, we have what we call a collaboration tool. Now, collaboration tool is known as Trimble Connect. Now, Trimble Connect is basically allowing people to collaborate within an environment where you can control the information that they see. You can ask them to do tasks, you can ask them to organize these tasks and so on, and we can upload into the cloud so that basically third parties throughout the system can use that system, so they have access to what you want to see or what you want them to see. So we're going to look at Tekla Structural Designer. And I'm just going to throw a few models up there. And as you can see, you've got some technical models, you've got some strange models, and I think that's a bit of a shopping center on the bottom left-hand corner. We can do high rise. We can do quite a lot of things in Tekla Structural Designer. So what is Tekla Structural Designer for? It has been purposely developed to allow structural engineers to aid them in their workflows and their deliverables. Okay, so this is a very simplified workflow that you usually have in engineering offices. And I'm not talking about any material or shape of construction. It's basically, it's what engineering offices do in a simplified manner for this presentation. So you've got to do some sort of modeling. Now that modeling could be just a quick drawing on a piece of paper to an advanced 3D model. It's entirely up to you. You're going to then do some loading, analysis, which is a mathematical analysis to get some forces or get your prediction. And from those forces and predictions of those results, we're going to look at some design. The design is usually to some code of practice or some form of code of practice, which is fine. But then there is talk around the world of something called performance-based design, which doesn't actually have to adhere to a code of practice, and the onus is on the engineer himself. But then you've got things like review and change, output, and then if you want to pass some information to somebody else. And the last one's important because you could pass that information on a piece of paper to a calculation sheet, to actually send a 2D drawing, to send a 3D model, and so on. So I'm going to break these down to all these individual parts. And I've probably talked about this as well. So modeling, you've probably seen some universities, at university you've done modeling. And what we try to do is create ourselves a mathematical analysis model, okay? Now this mathematical analysis model consists of literally 1D or 2D. Now 1D is basically a wire element, 2D is basically a plan plate. And what we do is we join these together using nodes and we try to predict some behavior, because what we end up doing is basically loading it, looking for deflections. From those deflections, we can apply things like Hooke's law and things like that, compare it to the stiffness of the material properties that you're using and try and get out forces. So that's what we do in modeling. And again, if you're using a wireframe of modeling, it's not a true representation of the physical model. Okay, you've just got to remember that. We're creating a mathematical prediction. Usually you import it by coordinate inputs and so on. And what it is, it is basically the classic method of how structural analysis has been done for the last 50 to 60 years, is using this wired mathematical method. The problem with this is that you can't use this model in the BIM environment when you want to do fabrication or you want to do something simple as just put a web opening in a beam. Can't be done because you've just got a wired element. We do things differently in Tekla Structural Designer. What we ask you to do is actually build a physical model, and we will take into account what we call the mathematical model or the analysis model. So how you generate the physical model and how you put in the actual members, the end releases, the fixities, the stiffnesses, and so on, we will create the adequate or correct mathematical model for you. And that's what we do automatically. You don't even see it. You just basically model, we get that. If you look at loading, which is the next step, because usually what happens in loading is that you place a load, and normally previously you end up placing loads on the wireframe that you've created. Now those loads on the wireframe then takes into account yourself, because then you have to display a bit of engineering knowledge, a bit of mathematical knowledge, and what we call decomposition knowledge, because all of a sudden you need to put the appropriate load onto the wireframe. So you're going to get manual decomposition because loads are placed onto elements and joints. There could be a chance of error. Simplified decomposition panels. Now, because advancements in computers and advancements in the mathematical model allows you to place what we call simple decomposition panels. And you'll see a lot of this today as we create the model and so on. And these decomposition panels have to be perfectly square and they have to be supported on all sides. But again, it's another estimation of loading. What we do in Tekla Structural Designer is that we allow you to put loading pretty much anywhere. Okay, so we allow you to do the original element and nodal loading, but we also allow you to do advanced panel loading and anything you can think of. So again, you've got maybe diaphragm loads, we could talk about that, temperature loads, settlement loads, and so on. What happens here is that we're not asking you to basically perform the decomposition in your own hands. What we're doing is put the loads where it's supposed to go. If it's in the middle of a slab, put it on the slab and we will decompose it. We actually use a finite element method of decomposition. So again, what we're asking you to do is on a floor plate, pop your loads exactly, and you can see difference between element loads, wire loads, panel loads, point loads. But again, they don't have to be on the wire frame. And you can then decompose that as you wish. What then follows is analysis, okay? And what we then do is we run analysis. Now, most products or most of our competition run a single set of analysis. So basically what they do is they run a form of decomposition, export it all to the wire frame, and that's it. They run the analysis, which is great. But then you've got the analysis there, which you're then going to look at the forces that are generated. And once you've seen the forces that are generated, can you make a change? Do you have to run the whole analysis again? How do you re-evaluate an analysis? Remember, we're looking, when you say analysis, we're looking at a mathematical prediction. And if the mathematical prediction does, even though it says a load of ticks on the computer program, but doesn't show how the building is behaving in true life, your analysis is wrong. What we do in Tekla Structural Designer is that we run multiple analyses, especially for concrete structures. We actually run an analysis which is a decomposition analysis, so therefore you get the correct loading to the decomposition of that load to the stiffness of the element. Now, if you were running, for example, a concrete design, we actually do 3 different gravity analyses. We do something called a grillage analysis, which those that have done a bit of decomposition will know that we look at the tributary area and decompose from there. And then we can do like an FE analysis and a 3D frame analysis, all handled in Tekla Structural Designer. But the beauty of it is all that data is held within the product, and the worst case value is applied to the design, which you're going to see in a few seconds. So for concrete structures, automatically we run 3 types of analysis in the background, and the worst case is used in the design. So that leads us on to design. And every country around the world will have design codes and have in-house solutions, okay? Now, our competition use separate modules. So 9 times out of 10, what tends to happen is you extract a single beam into this module, you run a design, and that size changes, or the stiffness changes, or the material could even change, for example. But now if you've changed something of that nature, your analysis is out of date. What you've got to do is replug that back into the main model, rerun the analysis, and then because you rerun the analysis, you have to recheck that object again because of the changes that you've made. It may attract more load, it may attract less load. But then the changes that you made will affect every other element around it. And again, it became like a manual checking for everything that you wanted to do. There's things like design rules, so such as like effective lengths, for example, especially in steel, where you have to adjust the effective lengths. You have to take into account theoretical forces, such as small moments on columns, for example, and these are for robustness. And then what can you do? Can you do further engineering, such as can you put that beam to be a castellated beam? Can you change that beam to just put a single web opening in there if it's just a wireframe model? Could you do composite design? Could you make it into a plated section and change it to a plated design? This is the reason on a wireframe model are further engineering designs possible. Because we have the physical data and the analytical data, we will provide a regional code-based compliant design automatically. We have clever technology such as group design. For example, in effect, when you have a model and you hit the design button and you look at the design, you could possibly get every single serial size in a catalog connecting into every other serial size in a catalog. What that leads to is a whole host of, for example, connection design and a lot of work. Okay, so therefore you want to optimize that design. You may want to group similar members to that design, and then you want to maybe do further design. But the beauty is can you practically see how effective that design is? And then if somebody asks you, where does that design result come, or which code of practice is that checked from, how easy is it to retrieve that information? So this is the biggest one for us, is review and change, because don't get me wrong, every product does the first 4 bits. We do a few extra bits in the loading and the analysis, the design. Some parts will do a full design, some do partial design and so on. I think we do quite effective parts in design. But how easy is it to understand the design that you've created? For example, you will find yourself as young engineers or senior as engineers creating a model, but then somebody else within that office or that department or so on will basically want to review that design. How effective is it? How easy is it to make a change? How do you make local changes? What I mean by local property changes is that to that element. Could you change that element to be a concrete element? Could you change that element to be something different? Could it make a global change? So all of a sudden then go, actually, I don't like that floor being concrete. Let's change it all to steel. How easy is that to do that? So what we've created in Tekla Structural Design is a dedicated graphical review, which is color coded. The ability to adjust the model's properties locally for that individual element or globally to the overall model instantly. You can instantly get quantifiable results, and you can have the ability to compare different design schemes. Okay, and we find this is a massive area because you're going to get checked on going, how effective is this design? Can I reduce the weight of this design? Can I get more ability to can I change this, or can I move a column? Can I do and alter the design? But again, once you've done the design, you hit the output. And don't get me wrong, lots of people have the output, which, to be honest, in the UK, where I'm from, you have to keep the output or an electronic copy of the output for at least 15 years. Okay, so again, when you have output from certain other products, how easy and presentable and understandable is it? Yeah, how accurate is the material and design? Can you get effective drawings out? Can you get quantifiable reinforcement out? Can you get quantifiable weights out? Can you get quantifiable lengths and measurements out? Can you get surface areas out? Why surface areas? Well, you might need it for painting, you might need it for fire protection. So what we've built into Tekla Structural Designer, instant reports and sketches, fully controlled, regional compliancy, full detail levels in the calculations where you can have 1 pages, you can have 20 pages, to all combinations, all analysis controlled. And basically we've got drawing formats available in DXF format. So just going to output. And the last one and not least is, at the moment, the biggest thing around the world is effective communication and handling data. So do you have to start from scratch, which I'm going to show you today, or could you actually import, let's say, an architectural model and start from that? Can you export out the model that you've created? And again, information that you have basically got, instead of somebody looking at a drawing or a calculation sheet and starting his fabrication model from scratch. So with all our products, and even Autodesk products as well, we have basically a dedicated integration process. And what I mean by an integration process, and you'll see this a little bit later today, is the ability to pass information from one element to another. But what I'm going to show you today is basically the standard way of passing information on. We now have an API, which is an application program interface with all our products, which allow you to basically do it, I call it through the back door, with a little bit of programming knowledge, which then allows you to pass information quickly, efficiently, store it in the cloud, and then you could use Trimble Connect to communicate that information. So these are the regional codes of practice that we've got inbuilt currently in Tekla Structural Designer, with again showing the different types of buildings that we've done, from walkways, multi-structural, lots of steel, lots of concrete. So again, we can design a fair few elements in steel and in concrete and precast. We can design elements for foundations. You'll see a little bit today of pad and strip footings, pile cap designs, raft foundations and raft pile foundations. We can do timber members as well. And this is where our connection with our other programs come in, because you can now do group design, individual design to timber instantly. And the idea is when you see Tekla TEDs next week, you actually see an interface. You will actually see how we can control that interface and control the input. But we call this another method called headless, where basically we're using the Tekla TEDs calculation engineering engine in the background, but you never see it. It takes that timber, takes the calculation, runs a calculation to a code compliant check, and then returns a pass or fail status without ever seeing Tekla TEDs. Couple of loading possibilities that you can have. So again, we have element, panel, structural. We have unlimited loading elements in Tekla Structural Designer, so you can go to your heart's content. But again, that's in individual load cases. You can have unlimited number of load cases. Those load cases can be in load groups again, so they can be inclusives and exclusives as a design of load groups, mainly to do with the industrial class. Then you've got combinations, and you can have a limited number of combinations to the correct code of practice. So again, this is showing Eurocode, but Eurocode has different factors of safety that needs to be applied to the combinations. And then you can envelope those combinations. So therefore you can put those envelopes together and you can see a global result with several envelopes in one. And we apply things automatically because we have the physical model as well as the analytical model. We can apply simple things like notional forces or equivalent horizontal forces, depending on what part of the world you're in, and things like diaphragm loads, which is literally applying a universal load on a floor and asking the building to twist. Analysis capabilities. Oh, here we go. So what we can do is these forms of analysis. So we call them first order design. So you'll hear a lot of this of first order, second order, non-linear, and so on, P delta and these sorts of designs. But as you can see, this is what you would get out of a book, and you could properly do with a hand calculation up to a point, because then the geometry gets quite difficult, the loading gets difficult, and then you will need a computer program. But we can do first order. We can do dynamics and second order, because we need dynamics when we're looking at modal vibration, which is literally, we're looking for the natural frequency and, forgot the term now, never mind. We're looking for the natural frequency and the associated mass with the natural frequency when we're looking at seismic, to apply seismic loads on there. And you will see that we can do seismic in a first order seismic and a response spectrum analysis and a second order RSA analysis. So again, we've got quite a lot of capabilities for you to get yourself design results, design forces out so that you can conduct a code compliant design. But like I said to you before, we do multiple analyses. So quite simply, we create the physical model. Automatically in the background, you never see it. We create the analytical model. And we don't just create one analytical model, we actually create several analytical models. So our competition will just create the one, you run the analysis, look at the results, and off you go. We can create several, because the first thing that we do is, because you can load in between wireframes and onto the panels, we run what we call a finite element decomposition model, so that basically we get the correct load. So you can see a line load here that we can correctly place onto those areas. If you put a point load in, for example, into a corner, you can see that the correct loading decomposition has applied to the main beams in that corner. We then, once all the wireframe is done, we can run a 3D building analysis, which is great. This is typical of what all our competition does. But we then have other analyses. So what we then can do is a slice by slice analysis. We can take a floor and then we can load that floor. We can then apply all the loading, because the difference is, in a 3D building analysis, you can get lateral effects affecting the forces applied gravity in a gravity condition, especially if your building is not has not got adequate lateral stability. But then we do these analyses, and these are gravity grillage analysis, which is a floor by floor analysis, which again allows you to have just vertical loading on those members, which will give you a different decomposition result and different analysis forces. We can then, what we do is a gravity floor by floor FE chase down. So you can do an FE analysis of one floor to another floor to another floor, chasing the loads down, which will give you a different set of results. And once we've got all those sets of results, you've then got the option of going, you know what, I'm not interested in all those. I'm going to do a full 3D mesh of the whole model, let the loads go where it wants to go, and I'll do a design on that basis. So we have a 3D meshed analysis option. We've got a lot of data. Okay, so for example, Tekla Structural Designer, let's take this 20-story, quite simple model. It has a number of 1D elements, a number of 2D elements in that analysis. That analysis basically will have individual nodes with analysis forces within each one of those nodes. And as you can see here, you can extract that information quite easily and quite quickly. Here I've just put in the end nodes, for example, but normally you'll have 3 nodes, 1 in the middle, 2 at the end, with all these forces. Now remember that you could generate and look at that information to a single combination. Not a problem. I can run a design, look at those forces, run it to a single combination. But in Tekla Structural Designer, you will have the capability to do unlimited number of combinations. So then for an EC design, which is a Eurocode design, for that structure, I could have quite easily generated 326 combinations, all with different factors of safety, all with different analysis and analysis results for each one of those combinations. But then with all those combinations, if it's a concrete structure, you could have done it to 3 different analyses, which then leads to a lot of information. The beauty of this is Tekla Structural Designer handles and organizes all the data and provides the appropriate value for the appropriate design check. So it doesn't matter which analyses it comes from, doesn't matter which combination it comes from, it will provide it in that check. And guess what? You can double check this. So I've taken one column out of there. If, for example, it's a concrete column. Straight away, we can see that different combinations, no matter each one of the stacks, now this could quite easily be a steel stack, is from a different analyses and different combinations. You can find all information by just expanding the left-hand side. So you could take a stack, let's take number 17. This is a little bit concrete, but it's found out that the worst case information was in the building analysis. And then if you expand the building analysis, you will see the code compliant design, all the checks that it's done, and the information that it's found. So for example, the values that it's got, I think it's got 100 and something over there, that value can be extrapolated and you can find that value in the analysis results to that combination and that correct analysis. So again, all that information is immediately there for you so we can verify exactly what we're doing. And what we want to do is that we want to eliminate what we call this black box, which lots of computer programs do. And it's a bit like, here's the answer, but how do you verify it? Where do you get that from? And so again, it's a lot of information there, but we handle it automatically. You don't see it and you get to see the instant results. But before we even get to that far, inside Tekla Structural Designer, we do what we call pre-model validation checks. So for example, we've got a whole load of checks to ensure that your model will pass the analysis routines. Remember, it's a mathematical model. We need things to be connected. We can't have things floating in midair or the joints or the wires not connected. We do all those checks for you so that you're not going to hit the design or analysis button and the product falls down. But once you've done the analysis, and remember, every time you do an analysis, we're in the elastic limit. What it means by elastic is that nothing ever reaches the plastic limit, which is basically anything's about to snap, break, buckle, or bend. So basically, your model can go to the moon and return back and give you results. Okay, so here we do what we call a global node check, which allows you to see instantly positive and negative to a particular combination. Is my structure standing up? And because your structure literally can literally, you see your structure standing up with the loads acting down on your structure. In the analysis world, there is no limitations. Degrees of freedom can go on forever. I've seen structures in the analysis world which has hit the floor. Now, you're thinking it's hit the floor, it's hit the ground, so it can't go any further. But actually, in the analysis world, it hits the floor, rotates round, and nearly goes back up on itself. All of a sudden, the torsions that it's generated at the bases have given an uplift force that reduced the actual force from the columns to pretty much zero. I've seen that happen. So again, we need what we call a global analysis to ensure that your model is standing up, and we'll give you warnings or failures if we find that one of these analysis nodes have gone past a meter. We've got a processor which is called a solver, and our solver is pretty slick because you're going to encounter what we call degrees of freedom. And as you well know, we have 6 degrees of freedom in translation and rotation. Sorry, 3 degrees of freedom in translation and rotation, 6 degrees in all. And if it encounters one, our solver can quite simply eliminate that movement and go, I've eliminated that degree of freedom. What you've just done when you see that solver error message is that you've added extra stiffness on your building, which isn't there. Because the solver is programmed to get to the answer no matter what. So again, you can see the complete solver process. And we have analysis solver check. So again, here in certain areas, if the solver doesn't get the correct reaction at the base, and you'll see this in the next one. So any degrees of freedom, for example, it's not in equilibrium, it's encountered something, it will point you to exactly where that is. And what we also give you is a loading summary check. Is literally whatever load case you've got or whatever combination you've got, it should equal to the total reaction. Whether you're looking at a load case, the total reaction in X, Y, and Z needs to be there. Whether you're looking at a combination, the reaction of X, Y, and Z needs to be there. So again, all that is inbuilt into Tekla Structural Designer. Again, talking about concrete, but we've got a fabulous way of designing concrete in 2 directions with reinforcement, top and bottom, all in one go. And in areas where you may need extra concrete for such as punch and shear and top reinforcement, we have a panel and patch method to do that. And this is usually found on continuous slabs. So again, talked about punch and shear, we can design extra reinforcement. We have comprehensive code output. So again, you will see this today. You will see that the code output is exactly to that clause and where we've got those figures from. And again, you'll get more information. So again, you'll see the combination of where we've got this from. You'll see the values, and you will see what we call utilization ratios. We can create immediate drawings. So this is what we call the engineer's intentional drawings, so that you can pass this information on to a detailer. And for lateral loading, we've got quite a lot of possibilities. So we have this automatic wind loading. You can apply wind load via diaphragms, which we've talked about that before. You have simple wind loading if you just want to apply a point load onto the building. You can have simple wind loading on complex structures, so that basically things are stepping, things are not exactly straight. What you're actually doing is doing that loading via the diaphragms. But you could just apply loading to a central node within the diaphragm and just apply it on the structure if you wanted to. And again, every code of practice will have theoretical loading, which is not part of the analysis. It's not part of your structure, but usually it comes from the actual weight of the structure, which you will just have to, apply on your structure, and then basically do this. And then for certain parts of the world, you get snow loading, and we've got an effective method for snow loading as well. But we've got a higher level of design, as I mentioned before. Like I said, you can design to unlimited design combinations. We perform multiple gravity analyses. We provide all the information in there, and we can show you what's critical. So again, individual checks are done. We do intelligent grouping, so that basically in the group, we design to the worst case element or the worst case forces in that group, and we can provide the same section size to all those members. Now, you may want to do that, you may not want to do that, but within a couple of clicks, you could actually eliminate the grouping, and each one of those will be designed individually if you wanted to do that. So like I say, we've got high level of details and review management. So again, you've got, for example, a pass and failed simple check. So you can see for the code compliant result, you can see which elements have passed and failed. But what we also do is give a ratio. So for every design check, we give a ratio, and we can color code that ratio. So as you can see, some of these columns that you can see in this picture are only working at 20%. Which immediately says to you the worst design check for that column is at 20%, and you can see some of these beams at the top here at 20%. Great, I'm going to change that, and basically I can probably get away with a skinnier column. I could possibly get away with less reinforcement. I could possibly get away with less weight to that section size. Let's reduce the section size, so on. But there's other things that you can edit instantly via graphics, like diaphragms. Are diaphragms operating all exactly where you want them? Do you want a split diaphragm? Do you want different diaphragm thicknesses or stiffnesses? Can you check easily what is fixed and pinned? Can you edit the section of material if you want it to the computer to auto design it again to find the size that work in those positions? Again, that control is available instantly. And many, many more. So again, there's a whole load of this graphical and change management area that can explain your structure, explain your design, and pass that information on. As you can see, we give you quantities and outputs instantly. So again, you can see the number of elements, number of solver elements, concrete, and so on. Tabular data can show you that. So again, you can have length, mass, surface area, volumes instantly done. And these reflect any changes that you want to do at any time. Drawings are instantly available, reports instantly available. But there's a whole lot more in there as well. We have a whole area of foundations, from pad, strip, pile cap, raft foundation, piled raft foundations. We also have this, which is what we call parametric and generative design, and we've McNeil Grasshopper we've linked with. And what it is that people wanted at the design stage, or not the design stage, at the investigative stage, is to create an algorithm, a very simple algorithm of maybe a building, and you can see the scripts that it's created. So in Grasshopper, you can create an algorithm which gives you a script that creates that building. Now, very quickly, you can use Grasshopper you can use Tekla Structural Designer in the background to find information like deflections, to find information like design results, to find information and so on, and bring that information back into this area without even looking at Tekla Structural Designer and survey that building. And you could possibly then go, actually, I want my columns to be, instead of at 9 meters, 12 meters. I want my slabs to be a certain thickness. I want, and so on. So instead of you building a model, looking at the analysis, then building another model or changing the original model, what you can do is with a simple script, and we call this an input script, okay? You can create a model in Tekla Structural Designer. You can see the model being built with Tekla Structural Designer, or you don't have to. You can load that model, analyze that model, retrieve results back into Grasshopper, and make engineering decisions from that moment forward. So again, we've designed what we call parametric and generative design. Also in, again, this is a little bit of concrete, also installed into Tekla Structural Designer is what we call a rigorous slab deflection analysis, which basically allows you to look at the construction lifestyle of slabs in Tekla Structural Designer. So basically, as it's being constructed, what's the deflection going to be like? Then you put some loading on it. What's the deflection going to be like? Over a series number of times, you can take things into effect like temperature, humidity, sequential loading, and so on. You can see the differences of what happens into the in the section moduli, and the deflections will result in that. So again, you can give accurate results on when you want to load it, when you want to cast off it, and so on. All that is inbuilt within Tekla Structural Designer. So BIM capabilities, like I said before, easily to our sister program Tekla TEDS, which is our independent calculation program. We can then go into our own Tekla structures, which is our highly detailed BIM analysis, which allows you to detail steel, concrete, connections, reinforcement, and so on. We can go into Autodesk Revit as well, which you'll be more familiar with. And we have an API which allows you to link to Rhino and Grasshopper. But also, we can go to Trimble Connect, and we can do much more because we have the API with us. So what do we ask you to do? We ask you to model a physical model. You get the analytical model automatically for you. You can apply advanced loading. We do automated analysis, not just once, but multiple. We give you a code-based design calculations, and we give you total BIM integration of that model. And that's Tekla Structural Designer very briefly. So that's eaten up into the first hour. So let's just start a project. Ooh, let's just delete that for a second. And done. Okay, so let's get rid of that as well. Let's start from scratch. So what am I going to do? Quite simply, I am going to give you this simplistic model. It is a theoretical model, as you can see. There's a couple of levels of concrete, a couple levels of steel. There's a core going through the middle. I'm just going to show you briefly what it can be capable of doing. I can't cover everything I did in the presentation, but again, hopefully this will give you an indication of how easy it is to use Tekla Structural Designer. So when you start Tekla Structural Designer, you will get basically a ribbon across the top. You get 3 main windows. This is basically your viewing window here. Everything works on a tab sequence with the command line in the tab. Anytime you click on a tab and you click on a command line, it gives you an activation. So it tells you what you want to do in that command line. And what I'm going to do quite simply is start with the levels that I know. So I click on the, oh, sorry, before I do that, I go to home. I can click on settings. I can list out all the options, like click on design code, drop down the design code. We've got a fair few design international codes in there. I've got country settings as well. At the moment, I'm going to do it in US metrics because I can do it in imperial, but it does get a little bit tricky for me. So please forgive me. It will be in metric this time. And we have total material databases as well of whatever you want to do. So you can see the steel sort of grades that you've got. You can see the individual decking and connection and shear connectors and so on. And basically all I'm going to do is create this project really quickly, simply look at the design results, look at that, and hopefully let's see how quick we can do. Right, so that's the first hour. Here we go. First thing you do, to locate any structural object or any element in Tekla Structural Designer, we need a grid pattern. So I'm just going to go to the model, go to construction levels, and here I'm going to put in some construction levels. It's just levels that you know. As you can see, the first 5 levels will be concrete with steelwork on top. I'll concentrate more on the steelwork on top, but I just wanted to show you how quick and efficient it is to actually pass this information across. Press OK. First thing I'm going to do is create a pattern of grid lines. And again, what you'll find with Tekla Structural Design is you can do things graphically, import into dialog boxes, or literally play dot to dot. In the UK, we call it, there was an old kids program, thing that you used to follow the numbers to create a picture. You'll find a lot of that in Tekla Structural Designer. I'm going to create a grid system, press next. Place where the origin is, it's going to be 0, 0. I want to generate X and Y lines, which is quite simple. If I just wanted to create X lines, then I would have to say what distance I want them across, what style they want to be. Again, all that can be changed. How many bays in the X direction? If I could put irregular settings out, so I could put 1 meter, 3 meters, 6 meters, whatever you wanted to do. Press next. In the Y direction is the same. You can then rotate the box that you want it to do. I'm going to leave it at 0, and then you can put it on a slope as well, but I want it perpendicular, so I'll leave it at 90. I'm going to quickly press finish. We can do curves, so again, we can do an arc, quite simply pick, and this is where the graphical information comes into play. So again, you can pick the arc, where do you want it to be, where do you also want it to be, how do you want to click, and I've just created an arc at that point. Quick, easy, wasn't difficult, and so I can start putting in elements at this point. So what I'm going to do is I'm going to tile the view. So quite simply, I'm going to vertical tile the view. So now you can see the 3D view on the left-hand side, and you can see the 2D view in the right-hand side. And you'll basically see this in a second, because all of a sudden, when I start creating objects, I might create them in 2D, I might create them in 3D. So the first thing I'm going to do is create a 3D object in here. I'm just going to put in a wall. Okay, mesh concrete wall. Basically asks me, what is this property you're going to put in? And again, you've got a whole host of properties in there. I'm not going to go through all of them, but again, how does it act? Base level, top level, and literally I'm going to pick the points on the 2D view and draw in a mesh concrete wall. Done. What I'm then going to do is go into concrete columns. So again, still in the 2D view, go into columns, and literally I say I'm going to go up to level 5. I'm not going to spend a lot of time on this, but going up to level 5, and what I'm going to do is quite simply pick the size of the column. I'm not sure what it's going to be, but I'm just going to drop this down. It's giving you a default size, but I'm just going to edit this. And again, not a big deal, different concrete columns. Again, you've probably seen it, rectangular. I'm just gonna make it 650 by 400, doesn't really matter. I'm gonna turn this automatic alignment off, because what it allows you to do is if I put one in, it will automatically align it to the side of the grid line if you wanted it to do that. And it's got tips and quick modeling tools like this. If I untick this, then all of a sudden I could basically put in concrete, bang on, center, not an issue. And all I'm doing is clicking and dragging, placing the columns, where I need it to. Done. And as you can see, it builds it up in 3D. What I'm then going to do is, let's do columns again. Let's just do one more different type. And please forgive me, it's been a while since I've done this, but hopefully you get the gist of it. So again, click on automatic alignment off. Quite very quickly, and this is what we call the quick launch toolbar. You have some simple operations which you can then basically add to this area. I've just got undo and redo, so I can just undo that, pick a point, and this time turn off this automatic alignment, click on the points that I wanted to put the automatic alignments. Sometimes you need to zoom in, sometimes you need to zoom out. What you're using is simple mouse wheel and mouse control. Click to pop those objects in. Done. I put my verticals in there. All I'm going to do is go into here. I'm going to double click on level 1. It generates me a view of level 1. I'm going to put in some beams. I'm going to drop it down, create a new size for beams. I don't know, 650. I'm just putting some chunky beams. And again, it's a case of click and drag. And this time it finds the grid line, finds 2 columns, finds the associated position of those points, and it'll put in some concrete columns. The beauty of Tekla Structural Designer is that where it couldn't find a column, where it couldn't find another column, it automatically gives you all these node points that you could possibly click from instantly. Where you've got a beam, it automatically splits that beam into quarter, third, and half point nodes that you could possibly click from. You could press F2 and actually enter in a dimension from one end to another end that you could put an accurate position in. As you can see here, it didn't put me in a beam, so quite simply I can pick a point, pick another point, and again it splits that beam to quarter, third, and half point nodes, but it will also generate me the point perpendicular or along on that beam. Double click, and I could price in a beam. That's how quick and simple modeling is in Tekla Structural Designer. This is on a curve, but it's found me the intersection point vertically down on that beam, and you double click, and off we go. Quite simply then, we can then put in, for example, slab on beams, literally click and drag and put slab on beams in. I can pick one object, for example. I've got the properties of that object there. I can adjust that property, for example, to make it one way if I wanted to. And this happens with every single element in Tekla Structural Designer. But if I click and delete that object, I can just delete that singular object. What you'll find is if I click and drag, for example, multiples, you will have a list of that I can select. So again, I could independently select the concrete columns. I could independently select the concrete walls. I could independently select certain objects instantly and control those certain objects. What you then can do is pick any element, for example, and you've got a list of elements there. You can stroll through those elements. If I double click that element, I can have its individual properties, which is exactly the same as the properties in the properties window. But again, I can control that element. And you'll find that there's several ways of actually getting to the product or getting to the parts that you want to do. Right, the steel bit, dead easy. Double click on level 5, generates level 5 on here. I'm going to go to steel columns and literally put in from level 5 to level 7 because I want to have a sloped roof. And literally, I'm just going to go around and pop in some steel columns in these areas. And as you can see, the 3D model updates. I'm going to go to level 6 and just go to steel beams, click and drag onto steel beams. Again, similar process as the concrete beams, where you see a concrete beam, you're going to get steel beams. But what I'm going to do in here is something a little bit different. I want each one of these bays to have 3 independent beams in there. I could go to beam, could highlight this, could go to the third node, go to this third node, so click, and put in each one of these individual beams. But we've given you tools. So again, if you go to the edit command, if we create infills, for example, we'll pick number of infills, 2, for example, and straight away it's ready to go infills either in this direction or this direction. What I could do is actually drag on all of these and apply infills instantly because I've selected all the bays. Obviously, I don't want steelwork inside the core, so quite simply select, click, select, and delete those out of the core. Instantly done. I'm going to go to level 7. I'm just going to put some trimming steel around, and again, go to the model tab, go to beam, click, drag, and drag, just put some trimming steel around level 7. Oops, at level 6, I need to put in some sort of decomposition panel. So again, if we drop this down, I could put in a steel deck. I'm just going to put in a one-way plated steel deck with the default options, click and drag. Quite happy with that span direction. Remove the one in the middle of the core. That one's that done. Now that leaves me with the roof. Okay, so what I'm going to do is do the roof in 3D. So everything you saw was in 2D. Let's do it in 3D. So now I'm going to close all but this. Remember, these are just views, okay? These are views that you can control at any time. And the first thing I'm going to do is go to beam, zoom in, pick a point in 3D, pick a point in 3D. Done. Again, using the right mouse button, I can rotate it, pick a point, done. I could then go, right. Instead of me doing those 2 points, is there a way that I could work in 2D but still work on that sloped plane? Yes, there is. We could use this option here called sloped plane. Click on sloped plane, pick 3 positions on that sloped plane to define that slope. All of a sudden, under slopes, that view is generated. If I tile this view vertically, what you then can do is click on beam, pick a position, automatically it will put it into that slope. And this is how we get to create accurately our amazing 3D models on slopes and things like that, because it's really quick and easy to do. But again, like I say, you could go around picking individual points. What I'm going to do is hold the control button down, standard Windows command, multiple elements I'm going to pick those options. I'm going to go to the edit command. I'm just going to be the copy. And I'm going to pick a point for that copy. And then what I'm going to do, actually, I'm not going to copy, I want to mirror. So I'm going to click mirror. I'm going to pick a point, pick a destination point, done. Just dead easy, quick and simple, quick mirroring command. Go to model, pick a beam, pick a point, pick another point, draw it in a beam, draw in some other beams. And very quickly, and there's several options in the mirror command. For example, go to the edit, click on mirror, pick a point, pick another point, and within 11 minutes, I must have started a little slow, modeling is done. What I'm going to do now is to make life easy for me. I'm going to put in some sort of paneling on the roof, because I could easily, like I said before in my presentation, put element loads on these members, but what I want to do is put a decomposition tool on these members. So I'm just going to go to model, go to roof panel, and literally put on what we call a non-stiffness individual roof panel, like so. One-way spanning so that it can pass the loading from the steelwork onto those beams. I could use the mirror command again. So quite simply, just copy that one, edit mirror, pick a destination point. And again, you don't have to use the mirror point. There's other options that you can use. But again, I quite like using the mirror point, quick and simple. Pick a point, click mirror, pick, mirrored that one. And last but not least, I'm going to put on a roof panel like so. Oops. Now, again, if you try to pick something that gives you something out of plane, it won't allow you. What we mean by this is if you put a crease into that panel, it won't allow you to put in or select that point. Okay, so again, we thought about this. Most of the frustrations that users have is when things are not correctly aligned. And there we go. So that's our model created. automatically in the background, we've created the solver model for you instantly. And this is the mathematical model that you would probably get to create, usually at universities and things like that. But we do this automatically for you. So we've got the physical model, we've got the solver model, and we do clever things like rigid arms and things like that. So you didn't have to connect directly into what we call the nodal position. You could have connected into anywhere on the physical emblem of that point there. And I showed you the nodes around the point, and we will connect it back to the individual wire positions for you. So we do a lot of clever things like that to help you create this solver model. Right then, click onto loads. And what you'll find is we'll work our way across the tab. So we've got modeling, bit of editing, loading, analyst, design, any extras you want to do, output. And then finally, BIM integration, and so on. So you could have brought this model in from Revit, and I'll show you a little bit of that in a second. But again, what have we got in here? So if you click on load cases, we give you some automatic load cases. So you've got roof, snow. Again, editing this, we can edit this, and I can call it general. Oops, if I can spell, for example, change this to be dead, and you can add as many load cases as you want. But like I said to you previously, we tend to do things graphically. So again, you've got included in combinations, any brittle finishes, and so on. All that information is available to you to edit anytime you want to. Oops, pop that over there. And what we're going to do now is apply some loading. So I'm going to take a floor. I'm going to take floor 1. Literally pick, oh, did I cancel out of that? All right, I'm just going to pick a load case, call it snow, and literally show you the different types of loading that we've got in Tekla Structural Designer. So quite simply, I can put on a slab load. Again, the properties window asks you what type of load you want to put this in, and again, direction, how would you want the element. Literally click on the element, and you're going to put everywhere you've got a slab, you've got a load. Because then if I go into 3D, pick that load case, all of a sudden you can see that load being applied onto all those load cases. You've got options in the scene. What I'm saying to you is this view has different options. So if I click on scene content, if I go to loading and turn on the text, press OK, somewhere you will get that loading. If I highlight that load and change it to something else, it is applied that load. If I delete that load, now I can press the delete button, or I can press the delete on the keyboard, I can delete that load. And everything you see in Tekla Structural Designer is done graphically, okay? So we don't hide anything. It's, again, it's for you to see the loadings that we've applied on the structure graphically. So let's apply some loadings. What I'm going to do is take the floor loading. You can see the different type of loading that you've got. So a level will be uniform across that level. Slabs is where you've got slab items. Area would be in an individual bay. A point load could be absolutely anywhere. There's a slight step in a point load because you have to pick a reference node. You have to pick where the point load is. Let's just quickly turn on the text. Yeah, not press OK. Yeah. Okay, and you can see where that point load is acting. What you can then do is select that point load. You could change the magnitude of that point load. You could then change the X position. So we could put that at 2. We could put that at, because this is all reference to the reference node of where you wanted to put it. You've got line loads. Again, pick a reference node, draw a line, can go through other lines and so on. You've got a patch load, which then allows you to pick the corners of a rectangular patch and put it at a slight angle. You've got a variable patch load. Sorry, you've got a polygon load, which allows you to create any shape you want to of the polygon. But that's a uniform polygon load. We've got a variable polygon load where you can control the different values of the polygon that you want to create. Go back to beginning. And this 2D view can be flipped to 3D, and you can see the magnitudes of those loads in 3D instantly in front of you. Done. So what I'm going to do is some simplified loading. I'm going to delete this load case. So quite simply, I'm going to just drag this back across. Just didn't delete the snow load case. I'm going to call it dead floor, live floor, roof dead, roof live. So I'm going to swap these around. So that's going to be a dead load. That's going to be a live load, roof live. There we go. And again, you've got options for pattern loading. You've got options for live load reductions. There's stuff in here that I'm only going to touch the surface of. But again, a lot of options for the engineer at this point. And what I'm going to do is just do everything in 3D. Because I'm lazy that way. So I'm just going to pick dead floor. I'm just going to put a level load, an additional dead of 2, for example, on that floor and on that floor. Dead floor live. I'm just making these up. Let's say 4. Pick on that floor, pick on that floor. And then I'm going to go roof dead. I'm just going to put on an area load, manipulate the view to be horizontal, click and drag, and then I could put a roof load in here and a roof live. Oops. And I'm guessing in Canada you will have snow loading and so on, but you get the gist of what I'm trying to do. Let's put 1.5, click and drag 1.5 like so. So I've loaded it, ready to go to the analysis. But before I do any of that, some things that I should have been doing all along the way is clicking this, what we call validation button. And what the validation button does is that pre-check before you do the actual design. So quite simply, if we go to the status, it tells me straight away, model geometry is absolutely fantastic. Meshing, decomposition solver. If I wanted to export this now, it would be looking good because obviously things are connected and things are looking good. Let's cause a mistake. So what I'm going to do is a mistake could be click a beam in there. Oops, click a beam in there and click another beam in there, totally separate to the structure. So I'm going to validate it now. The first thing is validation will cause a yellow triangle, and you'll find that this works in like a traffic light system. So you'll have things like green for go, all good, passing, perfect. A red cross, can't go any further, you've got to correct it. And a yellow triangle, orange triangle, which basically says, it's okay, but I'm going to give you a warning and you need to have a look at it, but it allows design. So straight away under here, validation is outdated. Shows you analysis is an issue. So again, validate it again. And what I keep telling anybody that's using Tekla Structural Designer, keep validating, 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 because what it will do, it gives you that intention of, hang on, things may not be right. So a model somewhere at the base is not, a member at the base is not supported as intended. So if you double click that, great, shows you that. If you double click that, great, it shows you that. If I didn't have the 3D view open and I had the 5th floor view open, and I went to validate and double clicked that, what it will do is find me an appropriate view, so it shows you the problem. And it'll give you a pointer that shows you, hang on, this is floating in 3D space. What I then can do is if I hit the title, double click, it'll show you all those in a 3D view instantly. So again, if you find a degree of freedom, if you find lots of things that you're not sure about, Tekla Structural Designer is designed so that you will get to that stage where you hit analysis and design. Working my way through, clicking on the analysis tab, you can see all the individual tabs that we've got for the analysis. So again, first order, second order, buckling, because people try to run a second order and find that the element that they've actually put in is not stiff enough to actually find that it works. So you've got buckling analysis, we've got seismic in there, first and second order, and so on. This is all to get you a code compliant design out. What I'm going to do is click on the design tab. So again, you've got design gravity, design steel. So you could just look at the gravity design. Whoa, wait a minute. one thing I forgot to do is create combinations. So we've done our load cases, we didn't create combinations. So again, I can click on the add button, I can click on the combination tab, and straight away, I've got all the available combinations, including notional loads in 4 different directions, which I can add across into this combination and give it a combination title. Okay, so it could be combination 1. I can go in here, adjust the strength and adjust the service factors. And again, you will get different factors when you have roof live and so on. And you can see what parameters you want, or which code of practice you want, and what effects that you want to apply. Okay, all that is available to you. I ain't going to do that because what I've got is a code generator. So again, literally all I need to do is go to next. It fills out what I want to do and which ones I want to generate. Press next. What I want to generate for service. Do I want to apply notionals, which I'm quite happy to. And again, there is an individual tick box in here. Press finish, and those are my combinations automatically generated. So you've got ASD, LR, FDs. You want to apply a camber to a particular combination. Again, this is for steel as well. Press OK. Created that. Always check to validate. Model's good. We can go to design. And if I only had a steel project, I could do a steel gravity or a full design, 3D design. If I only had concrete, but because I've got both, I'm literally going to click on design all. I'm going to show the process. And as you can see, it's going to do a whole load of things in the process. As you can see, it runs the solver, it finds the design, and you're looking for ticks. Okay, you don't want to find things like, you know, degree of freedom has been found and therefore been removed, because what you've just done is added extra stiffness into the building. It's running group design, it's running element design, but also it will tell you when there's issues. So for example, my material and my material database should be updated to the latest version. So I'm not using the latest version, naughty me. And it's running the checks of the elements, and what you've got is we've got 13 groups, we've got 17 elements, we've got 83 chase down elements. It's found out that 2 elements could be placed in an individual group, so it's doing the design of those individual groups. Then it's doing the shear walls, and in less than a minute, it's done a design. But this is the biggest thing. Every time I do training or do a consultancy or I teach people on structural engineering, all of a sudden they go, ah, don't want to see that. Ooh, look, some things have passed, some things have failed. Why have I got a warning on that? And straight away they fly into the design. Always is a big no, because I want you to do what we call the post design checks. First, check the solver. Ensure that nothing has happened in the solver, such as a degree of freedom or an analysis error. Once you're happy with that, go to the status window. Check the status window. I have an issue with meshing. So what's it done? Of quality. Interesting. So I've got an element quality in concrete. Below the warning, double click. And straight away, it shows me an element of poor quality. So what has happened in here, it's like it's done some meshing. Okay, once it's done some meshing, what it's found is that the length of one side or 2 sides of the triangle is really high. So basically the center of gravity is low, so therefore it may not distribute forces, decomposition correctly. But again, instantly I could double click, check, am I okay with that? Okay. And again, this is showing you the solver view. So again, advanced solver view, I didn't do any meshing. The meshing is all done automatically for you. So we'll ignore that one for now because I'm quite happy with it. Next thing I'm going to do is just double click on design, click on overall displacement. And normally, if you find that a single node, and you can see all the nodes in this view, has passed over a meter, it will give you a warning. Okay, so again, if you double click or if you right click and highlight node, tells you that is the worst case in strength in the X direction to that combination. That's the worst case in Y in that combination. This is the worst case in Z. I'm guessing it's a raking beam, a floor beam somewhere. Once we've got that information, you can see what any negative displacements as well. So again, right click, highlight node, right click, highlight node. And then you can see unfactored options as well. So again, positive area, right click, highlight node, information instantly available to you so you can check your structure. And the last area you want to check is the loading summary, which is this one. And you click on the loading and you want a tick next to all your load cases and combinations, because then you could highlight a load case and literally look at, okay, it's a dead on floor. Have a look at all the notional loads. Have a look at the actual decomposed load. So I've got 4,000 something. How does it work on the one-way decomposition? How did it work on the 2D decomposition? Did it give me a reaction? Scroll it down. Look at the FE chase down, look at the grillage chase down. Did it give me the right reaction on those two? It did, so the total load equals total reaction. I'm happy with it. But then what I could do is look at a combination, and you could see the total number of member loads, your total number of notional loads, so it's an invisible, theoretical, natural force that you've applied, and you can see the total reaction in X, Y, and Z that it's totaled up from all the reactions. Once you've got confidence in what you're doing with the analysis, now we can go look at the design. But first of all, let's show you the analysis. So under here, we have what we call regime. So you can see the one model that you've got, but we've got different views for that model. So you can see the structural view, right click, you can see the solver view, right click, you can see the results view as we're going to be in. And what you just saw there, we call the review view. So basically you can see the status of the design. So in green, it's passed. Red will be a warning, error, beyond scope, and unknown for something or other. What we then can do is look at the results view. And in the results view, we can see results. So again, let's have a look at reactions. So we can then look at, for example, total reactions. We can look at per load case, and we can turn the text on for the reactions, and we can see the text for the reactions. We could see the reactions for a first order linear. We could see the reactions for an FE chase down. We can see the reactions for a grillage chase down. And as you can see, they're going to be different. We'll go back to first order as we looked at it. Instead of reactions, you can have multiples on screen at once. You can see the actual loads in the columns, not much in the steelwork stuff because I didn't load it that much, but you can then turn on your forces. Remember, this is a load case. Switch to combinations. Click on combinations, so click on a combination, and it'll generate the forces on those combinations. And then once you've got your total reactions and you've got your results, we could look at deflections if you wanted to. And you can look at the deflection diagrams, and we can increase the deflections like so. And as you can see, it's deflecting at the top. If we right click and animate, and we can animate those deflections. So everything that you wanted to see, you can see. These are basically 1D analysis results. Stop that. Where's the, no, there it is. It's on my other screen, just bear with me. Close that down. So those are 1D results. You can actually see 2D results. So you can actually see FE results instantly. So if you do an FE chase down, and we look at FX, for example, and we look at a combination. So again, there's not much actually happening on here, but let's pick a better one. Let's look at MX. So again, MX in one direction, MY in another direction. You could see the reactions in the walls as well. And the beauty of Tekla Structural Designer is you can go to the scene contents in this view, and you can turn off the members, and you can turn off the slabs. Where's the slab items? And then you could quite easily see the information in the wall instantly. Okay, all this information is available to you. What you then can do is strip design. So let's just get a floor, and if you've got a concrete wall, you can draw a strip. So let's do a core line, select the entity, hang up the strip. Oh, can't get it working. Hang on 1 second. Do a result line, do wall lines. There we go. Result lines. Why can't I draw a strip? Oh, do I need to be in a 2D view? Possibly I need to be in a 2D view. Anyway, I can get that in a second. But once we've done that, I can go delete that view, go back into here, right click on structure, open view, and it'll generate me a 3D view again. I can go back into results, where am I going? Back into the review mode. There are my results. Let's pick a steel beam, right click, look at the checking of this member, check member static, and instantly you're going to get the design results of this steel beam. So quite simply, you can see all the design checks that it's done. You can see the different combinations that it's found, the design checks. There's some design checks that it's not required, but the issue is that you can see the design value, you can see the capacity, and you can see what we call the utilization ratio, which is basically what the capacity is as a percentage. So again, some things at 90%, some things at 80%, and so on. This happens again with concrete elements. It's just simply a right click and it's a check member static, and it's a similar thing, but obviously checks are different. And you can see what we call a design ratio of what you've provided, what its capacity is, and you get a ratio. So the beauty of that is once you've done a design, we can click this ratio button. And that ratio button gives you the worst case design check. So something's between 80 and 100%, and it's going to color it orange. If we look at that check again, static, and can you see something's at 90%, so it's right, it should color it orange. But instantly you can see all your members, and remember, you can click on this and go, actually, I don't want it to be concrete, I want it to be steel, like that. What I can do then on that steel column is I can right click on the steel column and I can go design member static. And all of a sudden, I haven't got the valid design combinations. So again, I need to go in. But once I've done and changed that to steel, the reason what's happened is all of a sudden I've lost what we call the design analysis. So what it had before wasn't adequate for changing it to steel. So what I need to do now is just quickly go back into design. Or another method that you can do is just go auto design check on and off. I can turn everything to on. So instead of that, go all on, box around everything, changed it to on, quickly hit design, design all static. And again, you can show the process window as it chugs its way through these, doing the multiple analyses. Give it a few seconds, gives me a chance to get a quick drink. It's going to quite lastly do the walls. So it's done it in 51 seconds this time, which is impressive. And all of a sudden, because I haven't loaded it that much, we can go check member, static, and this is the reason. It's found me a section size, which is not very big because this model hasn't been loaded. Everything's over exaggerated and it's loaded up. So the whole thing is the beauty of Tekla Structural Designer is you can change one element to a totally different element and run the design. If I decided to go in here, for example, double click on, not the slab, sorry, on here and change the size, for example, and pick the section, new and edit, drop this down to the biggest section, select, okay, big hunky section in there, right click on this hunky section, check the section. Why does it keep doing that? Interesting. No valid design combinations. Why hasn't it retained? Sorry about that. I'm not sure why it keeps losing my design combinations. I am on a slightly different version than the official one, so I possibly could have. Oh, interesting. Oh well. What I'm going to have to quickly do is just run the design. But actually, what I'll do is just click on this beam here, check the design static of that beam. Gives you a warning. And what it does is it basically gives you, and this could be for steel, this could be for concrete, and there's certain limits in codes where it basically finds that for this span and depth ratio, it's got a value. So therefore, it's giving you a warning. Tekla Structural Designer will instantly give you the reasons for that warning. So that information is all there. If I wanted to do foundation design, for example, I could click on foundations, quickly gone into the catalog, add a pile catalog. Now we don't design the piles, we just basically check into a given parameter. So I'm just going to basically call the pile 1. And I know this is steel, but again, you might have to do concretes and foundations and bearings. So literally, I'm going to put a pad on the bottom of here. I'm going to basically put a pile cat column on here. And all I'm going to do is literally have the ability to auto design depth, pile, and reinforcement. Not going to spend too long on it. Runs the designs you that. You can check the member, and that information is there instantly. You can see the information. You can expand further. You've got all the combinations listed. You've got literally all the information there. All that information is available to you instantly. I could right click on here, check member, oh, sorry. I could check that size. This is the really good thing. I could check that size and you can see it's failed, but then I could actually right click on here and design member, and it could design me that size to those forces. So again, all that information is there. As you can see, it's put in the correct number of piles and so on. I could, oh, things I forgot to show you is literally instant drawing. So right click on here, generate detailed drawing. And I need to drag this window across to here. And it generates me that drawing. It's a simplified beam drawing with a lengthened section, but that information is instant available to you. You could right click on here and open the report for member. Instantly done. Again, you can export a PDF, Word, TEDs, which I can show you next week. That information is instantly available to you. Close this down. And again, that was just what I call a one-page document, but again, you could have 20 pages, whatever you needed to do. What am I going to do now? Oh, I can do raft foundations if you wanted to. So again, foundations, we can put in a raft. So again, if I just get a view of the base, put in a raft. So let's put in a rectangular raft. Oh, sorry, not like that. So click on that one, click on that one, put in that. And then what you then can do is do a pile array if you wanted to. So again, you've got control over everything that you wanted to do at this position and this position. Make sure you click out the box and you can put in some piles like so. And then we can move them around so they can snap onto the grid positions, or you can be onto a slightly strange position like that. Close it down on the structure, and then we get the raft like so. And then what we need, the interesting thing about Tekla Structural Designer is that basically where you've got individual models for foundations and things like that, we don't do that. We actually have spring supports at our foundation positions, which then could actually affect our 3D model. So now I've put a raft in there. Those supports that we had previously are no longer valid. They are now going to be, so you can see the raft and the pile, they are now going to be spring supports due to the foundations, and I could run the design to those foundations. Okay, last couple of things that I'm going to show you. And again, all I'm doing is very quickly scratching the surface. You've got foundation ratios as well, so you can see how effective the foundations are working. You've got pile ratios as well, so you can see how your piles are working. So again, you can adjust and move the piles. So all that's available to you. What I'm going to do is go to the BIM integration tab, go to Revit export. I'm going to export this model into Revit. Pick the option, and I'm just going to, I've got one here named, so I don't have to type it into Revit. I'm just going to save it over the top, press yes. Why didn't it allow me to save it? Oh, there we go. Cancel that. Yeah, and finish. It's just a bit slow, my machine, all of a sudden. Exported. And then I'm going to look to the status area, and you've got the structural BIM export, got a tick. So I'm just going to drop this down, drop my presentation down, open up Revit. And in Revit, we actually have a tab in Revit where it says Tekla integration. We can click on integration. And this is the exact same process in Tekla structures. I'm going to show you that in a second. But again, import model into Revit, press next. Pick the file that you want to import. And it just shows our open collaboration policies, that anything that you've got contained within our software can be shared to other softwares via this CXL process, or even via what we call a BIM process. So via the API as well. Again, we've got some here. I might not have the correct options ticked. Off the steel plate. I've got to pick steel deck or steel something, that'll do. So again, what you're doing is mapping. So we've got a naming convention in Tekla Structural Designer. What we've got in Revit is got their own naming conventions, and sometimes they don't map. So what we've got to do is actually provide information to map it. And what you saw there is the ability to save that mapping once you've done it. And all I'm showing you is our collaboration here. I'm just showing it into Revit, but quite simply, I could have shown you this in our own Tekla structures as well, which I was going to do after this. So as this is going through, so in our own Tekla structures, we have a similar process on our collaboration tools. In a second, it will work. So I should have launched this up first. Sorry about that. So again, I can just pick an old empty blank model that I use, environments, whichever you've got. And let's have a quick look at the import from Tekla Structural Designer. So again, this is our BIM platform of Tekla Structures, which is a lot better. But then we can go down to here and you have the same option. So we can import directly into Tekla Structural Designer. Maybe I should have set this up first. So this is a blank model. What it's doing is trying to connect me onto resources online. Blank model, I can quite simply click, import, Tekla Structural Designer. Now what you will notice is that we have an option for our own Tekla Structures export, including an option to export to Trimble Connect, and we have a separate export to Revit Structures as well. So again, we've got a few issues here, a few warnings, but let's see what it's produced us. Let's go to Structure, View, 3D, and there's our structure in 3D. What can we do in this case? This is my last little bit to show you. I can go into structure. I could have the draftsman go in, click on this column, for example. I can change this column size to be bigger. It's not done it. I could add elements, for example. I could actually start playing about with this model, actually. Let's just add some elements. Again, if I go beam, 3D snappings on, I put in something, doesn't really matter. Pick a point, pick a point, pick a point, pick a point, like so. I forgot the key command. There we go. And let's just do this. Like so. So as you can see, why didn't that change? Interesting. Oh, okay, I did change on that one. Okay, I've just changed it to anything. So what the idea is, we can do what we call round tripping. So the idea is that individual parties can work, but they can collaborate the information together. Last little bit I want to do. Come on, get out of the way. How do I move this thing? Okay, Tekla integration, integrate again, and it pulls up a similar wizard. Press next. And we want to export that model and update an existing model. Pick the objects that you want to export. Pick the objects that you want to change. And again, there was a few errors in there that I'm just going to pop this back in. I'm just going to go to TSD1. And this is the exact same process in Tekla structures as well. And again, it just emphasizes our open bin policy that we do want to communicate with other parties. There's certain objects that have not worked, so what I'm expecting is certain things to work and certain things not. So now, in my TSD model, I can go to structural BIM import, pick the file, to TSD1, next, 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 next. Again, it's got an issue with steel for some strange reason. What have I got in there? I must have some object in there, don't matter for now. Press finish and let's see what it does. As you can see, this is the beauty of the collaboration that we've got, that we can basically control, collaborate, pass information from one product to another, totally separate products as well. I could have shown you exactly the same thing with our own product, but then it looks like because we're the same company, but this just shows you our open bin policy. The columns changed, steel beams changed, and you can see the items that are deleted. And what we've even got for you is in the review mode, and we click on review mode, you can see the BIM status, okay? So things that have not modified, things that have been changed, things that have been imported, and things that have been updated, okay? Because this was a continuous beam, obviously I deleted a slab, certain things have become updated. So again, it shows you how graphically you can control, understand, and hopefully use this flow of information to full effect. And that's my presentation for today. Thank you for your time.
Yeah, thank you very much, Anish. As you can see, I've got my hand up, or maybe you can't see that.
Yeah.
Software properly and follow protocols. But anyway, I have a question.
Sure.
Actually, I have two questions. One is kind of general. I'm just wondering, like, first of all, very impressive. Yeah, I appreciate the detailed overview of the product. Now, there are a lot of structural analysis programs, and a couple of times you referred to the competition, and some of them are pretty famous and widely used.
Yep.
You were to be talking to a large potential client who uses one of those competition softwares for structural analysis and design. What would be the sort of the main selling point for switching? And I'm guessing it might be related to the use of the physical model rather than the wire model, and its ability to communicate with upstream and downstream softwares. Is that accurate? I know there are different features and all of that, but
that is absolutely accurate. For example, my emphasis when I'm either demoing Tekla structural design is never the modeling side of things. It's actually, what have you got from the analysis? What have you got from the design? How do you control it? How do you review it? How do you change it? And it's always that area. And once you're happy with that, what is the flow of information? How does it make the information flow from one party to another? And I've just highlighted a lot of issues that I talk to clients around the world of other softwares. Now, you've got to remember, these are the softwares that have been around for quite a long time. This was developed in 2015. And we basically based our software on the transporting of information. And if you have the physical model as well as the analytical model, quite simply, then we can go, right, I want to change these beams to be composite. I want to do certain other things and so on. And that's where we stand head and tail in the competition, basically. And everybody's talking about BIM because of the collaboration. We make too many mistakes. People don't understand your intention as the engineer when you put it down on a piece of paper. And if you can pass as much information, which is controlled, of the information you want to pass, it's all better for the construction future. That's the whole thing.
Yeah, fantastic. My second question is more technical.
Yep.
I'm going to go out of character and talk about concrete.
Yep.
The experience that I have with modeling concrete is that it generates a whole lot of headaches. And when I look at, you know, the automatic meshing and you know, you have when you're modeling cracked concrete behavior, it's difficult to account for things like tension, stiffening, and
Yep.
you know, the tensile properties and crushing and so on. So my question is, does the user have any ability to step in and customize those types of things, or are they all internal?
Absolutely. What we've done is exactly what you just said there, is that basically we've taken all your headaches. First of all, meshing. You've so many times you get elements that are not correct and this, that, and the other. We've taken the time to look at the properties of modification factors of what would you like to use at certain times of cracked and uncracked sections and so on. We've taken the time to look at whether an element needs to be cracked or uncracked. So again, even in the review mode, and we looked at show alter state, and we look at cracked and uncracked, for example. So you set the value. You can look at, where is that? Yeah, assumed cracked. You can set the value, and then you can set, do you want to set it to cracked, uncracked? And we've given you controls of the values of what you think it should be as cracked or uncracked as at that point. And this will color code it as it should be cracked or should be uncracked. And you can set that in the properties. We've given you a whole workflow that you can work to. And because we've taken on board an account of all the heartaches and the headaches that people have, especially dealing with concrete, you know. And one of the biggest headaches that we've got is usually it's always in the drawing. So basically, it was basically, if I just pick a floor very quickly, have I got a floor on here? No. It was just relaying information, and this is it. If I pick a floor, pick a beam schedule, for example, and instantly create a beam schedule. So again, we can give you information instantly of schedule, centers, and so on. That's available to you at a click of a button, okay? But if I go into drawing management, if I go into beam details, for example, and this is the areas that basically a lot of people have said to us, this is the areas that we need to pass information to other people and create information, but it has to be what we call, has to be live information, if that makes sense. If I make a change, I need the information to be, and it's generated to reflect that change and so on. And we've taken on board a lot of things that, this is probably the reason why people don't like dealing with concrete. It's a lot of information for what you've got. But here, as you can see, we've given you literally concrete beam, centers, curtailment, which you have control over, dimensions, which you have control over. And if we come across quantities, now those quantities are instantly available in Tekla Structural Designer, which I didn't show, which I should have done, naughty me. So because if I go into review mode, if I go structure, review mode, click on tabular data, instantly you can see the material lists, you can see for concrete columns, concrete beams, you can see for steel columns, steel beams instantly, and then you can create the information's always been available. In what I say to people is the information's there in the system. How easy is it to get it out, and basically how quickly can you get it out, and how relevant is that information to you? Because the information sometimes that you get out is not relevant at all.
Wow, lots of flexibility. Thank you for, should stay quiet and see if anyone else has any questions.
No problem.
Well, actually, I've got two questions of my own. So I'm wondering, you've showed the interoperability with Grasshopper
Yes.
and TSD. So is the workflow between them, is this like a live link that allows you to read and write at the same time?
Yes.
And so kind of a follow-up on that, is it, could it then be used, for example, for the generative design side of things in terms of running thousands of iterations on your model, getting the analysis results and optimizing for that, for example?
Yeah, what I've shown here is basically a one-step analysis. So what's happening is I'm creating the structure in Grasshopper. This video is a longer video, actually. There's one on YouTube showing this in action. I'm creating a structure. I pull back the deflections and I change the grid system. I change the heights of the building. I change that. Now what you can do is on the script is actually in the notes, so you can actually put down physical numbers. Instead of using sliders that this has got, it's gone try that, try that, try that, try that. What you then can do is basically grab information. So if you were doing such a thing as a space frame or something of that nature, and you wanted to change the different pitches, the angles, the width, that's everything's got. Again, all that is available, and to be honest, we've made another improvement in Grasshopper in this link one and in our link, because I can talk about it now because we're in the same quarter. In the service pack, which is going to be released next month, is that we basically then hold design information. So then you can actually run the design in TSD. Before, you could run the analysis and get deflections back. Now you can actually run the whole design and actually pull back and see what different serial sizes you've got and so on. But in YouTube, for those guys that you want, you will find, if you type Tekla, oops, I can't type today, Tekla Tekla Structural Designer and Grasshopper. There we go. Somebody's been already at it. And we've got umpteen videos in here, you know, how to model using the Grasshopper link and so on, parametric designs. By all means, guys, have a look. It's the best way for you guys to investigate further. But what we're finding is we're finding companies that want to do more of an investigative design at the beginning, and so that they're not stuck with architects sort of, this is the best way forward, because they have no concept of force loads and actual positioning of elements in the model.
Yeah, I see what you mean. Wow, that's really awesome. And I guess my second quick question is, I know, or I remember reading that you're currently developing the Canadian codes for TSD. Is there like a timeline on when that would be released?
That's over my head, unfortunately.
Yeah.
I couldn't tell you at this moment in time.
Yeah.
Everything's a possibility. But at the moment, we've got USA codes as international codes at the moment.
Yeah. Okay. Lovely. Sweet. Thanks.
Right. I just want to say thank you for your time today, and I hope you enjoyed the presentation.
Yeah, thank you very much, Anish. So just a reminder, we're listening to Anish Patel from Trimble, and especially appreciate that you're doing this in the evening in the UK. Very interesting presentation, and I have to say I wasn't that familiar with this product, but I feel like I know a little bit about it now.
Excellent. That was my whole remit. So I'm glad I've done that. So any questions, guys, you can email AJ or myself or the other guys on the call. Happy to answer anything that you might want to talk about. Okay.
Okay, so just remind everybody quickly that next week, I don't know whether you can throw up our slide there, AJ, or not, but next week we have a presentation from Steadfast Engineering, and they are going to be talking about the evolution and future of steel connection design. So again, let your friends know, and we'll move to that. And I guess will we hear from you personally, Anish, for the for the TED's talk?
Yes, you will. It won't be as long as 2 hours, but yes, I'll be there for the TED talk. So I'll be okay.
Okay, see, we're making friends. Okay, thanks everybody. Have a great day.
Thank you, guys.
Thank you. Cheers. Thanks, Anish.